So, in the last class we learned about a mathematical tool, that is the vector calculus, that is needed for learning electrodynamics and electrostatics in particular. Today we are going little bit further to learn about coordinate systems, that is coordinate systems that are necessary in learning in general physics, and as well as particularly we need it in this topic called electrostatics. So, in electrostatics we use many coordinate systems. So, the most familiar one is our Cartesian system that we already know, and now there is another one that is called a spherical coordinate system, and there is one more that is called a cylindrical coordinate system. So, we have this three coordinate system. So, I am just introducing you to all of them because we need the help of these coordinate systems to find the curl of electrostatic field. So, for that let us learn about the spherical polar coordinate system. Now, there is a point. So, you can see this point. The coordinate systems are always used to find or to locate something in space. We need to know exactly where it is. So, for that we need a reference. That reference is called the coordinate system or coordinate axis. So, in Cartesian system we use this kind of three coordinates, that is x, y and z axes, and the distance from each of these axes is measured as the coordinates. So, this will be the z coordinate and this will be the y coordinate, and there will be an x coordinate, or the projection to each of this will give you each coordinate that you are familiar with, and corresponding to that, to specify each direction there are three unit vectors, x cap along the x direction and y cap along the y direction and z cap along the z direction. So, now we are going to introduce a new coordinate system. So, why do we need a new coordinate system? Because we need to deal with symmetry. So, when there is a spherical symmetry or cylindrical symmetry, it is easier to work in spherical coordinate or in a cylindrical coordinate other than the Cartesian. So, it can be dealt with Cartesian, but the problem will become more tedious. So, it is better to choose a fine or a suitable coordinate system for each problem. That is why we are learning spherical coordinate system. So, in spherical coordinate system, a particular point P is represented with three coordinates. Those coordinates are r, theta and phi. So, here you see that r is the only coordinate which has a dimension of length, and theta and phi, they are angles. Okay. So, how do we define that? So, we define each of this coordinate with respect to an existing Cartesian system. So, we have an origin here. So, from the origin we can define a distance. So, this is not a displacement, this is just the distance from the origin. So, first coordinate r is defined as the distance from the origin. It is the distance. That means, why I am specifying distance, that is, here we can take another point. So, let this r is equal to 10 centimeter, and I can take another point here with the same 10 centimeter. So, another point here with the 10 centimeter. So, it is just a distance. So, if I fix this coordinate r is equal to 10 centimeter, then all the point with the coordinate r is equal to 10 centimeter, that means here, 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 you can take not a circle, a sphere in 3 dimension. So, it corresponds to a sphere, that is r is equal to constant will make a sphere. If you are allowed to change other two and keep r is equal to constant, then you will get a sphere. That is why we call it as the spherical coordinate system. Okay, now we have that is r. So, it is very easy to measure. So, take the distance, not the displacement, just the distance from the origin. Now, we know that now if we fix that coordinate r is equal to some 10 centimeter, you get a surface of a sphere. So, you need more coordinate to fix a particular point. So, the next coordinate is called theta, and theta is defined as it is the angle that is measured from the z axis, that is, or it is the angle between z and the r. So, r we already drawn, and what is the angle between z and theta, and that is z and r, that is the next coordinate called theta. So, we have r and theta. Now, what happens? Now, let me fix theta is equal to some 45 degree. Usually we represent it in radian. So, for simplicity I am using some 45 degree, that means degree measurement. Now, if I fix theta and r, what happens? So this angle must be always 45 degree. So that is the meaning of 10 centimeter. 10 centimeter means this is r, this is at a particular distance. And now if I fix, let us fix only, let us fix theta alone. Let theta is equal to 45 degree and I can change all other coordinates. Then what I get, so to fix theta, if I draw, you will get a cone, a surface of a cone will be defined. That means here this will have, this line will also, any point on this line, this r will make 45 degree, and any point on this line will make 45 degree, 45 degree. So you will get a cone. Okay. Now these are the shapes. Now we are not fixing into a cone. So now we have two coordinates. So the first one is r. Let r is equal to 10 centimeter and theta is equal to 45 degree. Then what would we get? We get, that is r is equal to 10 centimeter means this distance must be 10 centimeter always, and this angle must be 45 degree. Then what we get? We get a circle here. So every point on this circle, so this is the part of that cone, and every point on this circle will have a particular 10 centimeter r and a particular theta is equal to 45 degree. So we got a circle. Now it is on a line. Now we have to fix it into a single point. So we need one more coordinate system. So just carefully note that it is not that easy to understand the next coordinate system. The first two are comparatively easy. That is, one is the distance from the origin and the other is the angle with the z axis which made by the r, and there is a direction for that angle. The angle is measured from the z axis. So this is the direction of z. So that is important actually. Even though there is no direction for angle, or we cannot have, we do not use any direction for that, but we need that because to find the direction of unit vector. So next what we do is that we have the r here. R is a length, and we can project it, or we can take the component of it on the xy plane. Now this is the xy plane. So to get the projection of this vector on the xy plane, so not a vector, this line on the xy plane, what we can use is that just give some light here, some source of light here, and this will make a projection or simply a shadow. So that shadow will be something like this. So we get a shadow. So this is actually this r sin theta, just ignore the value, we will find the value later, and this one, this line is actually the shadow of this r on the xy plane. So that is the part of the next coordinate system. We are not completely reached there to the next coordinate system. Now just understand that this is the projection of this in the xy plane. Okay, now let's find the value of that. Just see that here you can see this line makes an angle theta with the z axis. So this line will have, this r will have a component in the z axis. What would be that component? We'll write it later. So I'm just writing. So this will be r cos theta, because the angle is made with this z axis. So this is r cos theta. Now this line or this projection is actually on the xy plane. That means this angle is 90 minus theta. Why this is actually 90? Why this angle is 90? Because it is made with the z axis and the plane xy. That is, xy plane always make a 90 degree angle with the z axis. So this is 90 degree. So the remaining is 90 minus theta. So this side is r cos 90 minus theta, and we know that cos 90 minus theta is sin theta. So we got r cos theta, sorry, r sin theta. So this is the side we got. Not yet we reached the next coordinate, so just wait for that. So that is how we got it as r sin theta. Now the last coordinate, that is this one, that is called the phi. So phi is the last coordinate. What is that angle? It is the angle made with the x axis by the projection of r along xy plane. That is, you do not bother about the definitions, but you understand that what is this angle exactly. So this is the angle between, this is the x axis, and what is this? This is actually the projection of this r in the xy plane. So the angle between the projection and x axis is called the phi coordinates. So now we got the all three coordinates, that is r, theta and phi. Okay. That is basically the coordinate. Now we can do something else. Okay. Now there will be correspondingly in Cartesian system we have three fixed direction. So that is an important thing, that is in Cartesian coordinate we have three fixed direction, corresponding to each of them there is a unit vector x cap, y cap and z cap, or more familiarly the I, j and k. Okay. So x cap and y cap are the unit vectors. So wherever you go, whatever be the distance from the axis, the x cap will be or y cap will be always directed along this. Here y cap will be directed like this. So the unit vectors has a constant direction in Cartesian system. But when we are coming to spherical coordinate system, let's see what are the directions of the unit vectors. So let's look into our coordinate system again, and you can see here. So this is our r direction. So the direction of r means this is the direction of r. That is, when we increase r to a little bit amount extra, or I am increasing r with a dr, what would be that direction? In which direction r will increase? That means, let me draw. So simply this is the r. If I increase r with an amount dr, very small dr, then it will be increased along this direction. So this part is the dr, this is the r cap, this is the direction of r cap. Now that is the direction of r cap, but there is a problem. Now if the point is somewhere over here, now imagine that our point is not here, now our point is somewhere over here. Now what is r? This is r. What is dr? Dr will be directed along this direction. So unlike Cartesian system, in this particular coordinate system or in spherical polar coordinate system, the unit vectors are not have a constant direction. They do not have a constant direction. Here it is directed towards here, here it is directed towards here, and it has infinitely many possibilities. So that depends on the point where you are. So based on that, the unit vectors may differ from point to point. So that is the direction of P. Now what is the direction of theta cap? So we can call this arrow as r cap, what we use for unit vector, that is the direction of unit r. Okay. Now what would be theta cap? So what is theta cap? Theta cap represents the direction of theta. So a very small increase in theta will correspond to this direction. So what is that? So let us see that. So okay, now there is a difference in the order. Now just consider this one. Now if I increase theta to d theta, so there will be, I will explain it later on a better slide with a better animation. Now just bear in mind that is now that is theta, here it is theta, and theta is increasing in this direction. And if I increase theta by an amount, then this will be the direction of theta cap, and r sin theta, when phi is increased, this will be the direction of phi cap. Okay. We will get back to it later with a better animation. So okay, now we need to interconvert between coordinates, that is this P will have a similar coordinates or another set of coordinates in Cartesian. So in Cartesian, let me represent its coordinate as x, y and z. Now what are these values in terms of r theta phi, or we can convert between coordinates, that is r theta phi, and we can convert in between x, y, z. So how do we convert in between? That is the question. Now here the x is, so the x coordinate is this, because this corresponds to the projection here, and this will be the x coordinate, and this will be the y coordinate, and this will be the z coordinate. So now using geometry we can find each of them from this figure itself. Now this length is r sin theta, and which lies on the xy plane. Okay, then let me draw this separately, that xy plane alone. So this, so that this is the x axis and this is the y axis. So this is y and this is x. Actually I am taking this xy plane and drawing it in a plane. So here you do not get much 3D effect here. So we are drawing it on a plane. So that is y and z, and we have this line, that is the r sin theta line. So this is the r sin theta line, okay, and this angle is actually theta, not theta, this is phi, okay. So now from vectors we know how to take the components. So this will have a component, so this r sin theta will have a component of cos phi component here. That means r sin theta cos phi will be here, and this will have a y component, that is r sin theta sin phi. So this will be a sin component. This is r sin theta cos phi. So r sin theta has two components, one is r sin theta cos phi and r sin theta sin phi. So this is our x. So that means our x coordinate is, r sin theta cos phi, and our y coordinate is r sin theta sin phi. So we got a conversion for x and y. So let us write that here. So let me write them. So x is equal to r sin theta cos phi and y is equal to r sin theta sin phi. Now what about the last one, the z? So here you can see this is r and this angle is theta. Now z component is actually the projection of this along this direction. So the projection of r along the z direction is actually the z component. So z component is the cos component of r, that is r cos theta. So we got it as r cos theta. So we can compute each of them individually. So that is about x, y and z. So now you can see each of them, how do they vary or how do we can convert between them. So we got a relation for x, y and z, then just square it and add, you will get a relation for r and divide between x and y, these first two equations, then you will get an equation to convert from phi. So you can find each of them very easily, and cos theta is equal to z by r. Instead of r you can substitute, that is the root of x square plus y square plus z square. So in the conversion, that is r is equal to phi is equal to and theta equal to equation can be easily found out from this equation, that is I am leaving for you. So that is about the conversion of coordinates. So that's it. Now let us go back to something else called the line element. So we already know what is a line element is in Cartesian system. In Cartesian system we use line element to denote an infinitesimal movement. So that means we have the Cartesian system something like this here. If I move from a particular point a certain distance, if I vary, or in other words if I vary each of the coordinate by an amount dx, that is if I vary x by an amount dx and y by an amount dy and z by an amount dz. So I am just moving along this through a distance dy, here I move with a distance dx and here I move with a distance dz. So they are all infinitesimal vectors pointed along the x, y and z direction respectively. So these three individual movement will cause a particular movement in the entire system. That means this will correspond to a line element, or in other words if I have a line element dl here, I can take that dl as a component, that is along each direction, that is dl can be decomposed into dx into x cap plus dy into y cap plus dz into z cap. So that is what is called a line element in Cartesian system, that is you are familiar. Now we want to find the line element in spherical polar coordinate system. That means what would be the line element if I change dr by an amount dr and theta by an amount d theta and phi by an amount d phi. So first of all So, before discussing about theta, so the most easiest thing in this is to find the r. So, the line element along r direction. So, let us see. So, let us see that is here I am increasing r by an amount dr, that is I am only increasing the r coordinate, not anything else, only the r coordinate I am increasing this along this direction. So, I increased r along this direction, and that increase actually dr is a length. So, the increase in dr is also a length. So, it will have a length dr, and it is directed exactly along the direction of r cap. So, here it is directed along r cap. So, dr into r cap is the component or the part of line element along the direction of r cap. Now, let us look into some more complicated case, that is of theta and phi. So, let us go. So, first line element we got it as dr into r cap for the variation of r. Now, let us go to the variation of theta. Now, we have r and theta here, I am not drawing phi. So, this is theta. Now, let me increase theta by a little amount, that is d theta. Now, I increased, so this is our point actually. So, where we have to look, here is the change in angle, but we have to look at this point. Now, this point will shift to the next point. So, I am only varying theta, or we are varying theta alone, and theta is varied by a small angle, that is let it be d theta. So, this angle is d theta, and that change in d theta corresponded in a variation of r, a rotation of r. So, first our point was here, the p was here. So, the new p, so the point is shifted from here to p dash, that is p is moved from p to p dash. Now, I can connect these two. So, now I can connect this two with a vector, okay, and that vector is the corresponding line element due to the variation in theta. So, here you cannot say that theta, d theta is not the line element, because d theta is not a line, it is an angle. So, corresponding to that angular change, there will be a linear change here. So, that has to be found out, that is why we took it like this. So, this is not that simple as that of finding in a dx, dy or dr or something. So, here we have to make a change in theta, and correspondingly we have to measure what is the corresponding change in length. So, that length is this much. Now, let us see what is that length, what that length is. Let me draw this much only. So, you can see, let me draw it something like this, little bit larger, no problem. So, this is r, and this is r, and this is theta. Now, this is our element. So, let me call it, we will call the name later, and which is directed along the direction of theta cap. So, now we know that, let me call it as some, this is some unknown quantity. Now, you know that this is a radius, and infinitesimally thinking this will be an arc. Now, we know that angle is equal to arc by radius, or from that arc this can be found out as arc is equal to radius into the angle. So, this arc is equal to r into d theta, and which is directed along theta cap. So, that is it, r d theta, theta cap will be the direction or the line element corresponding to the component of line element corresponding to r d theta or theta. So, that is about the second one. Now, let us go to the next one, that is the next is the variation of phi, what it causes. So, this is the case of phi. Now, we have a phi here, and this is r sin theta. Let me increase that phi by an amount d phi. So, I varied it by phi. Now, everything changes correspondingly. That means, if I vary phi to d phi, the correspondingly the r sin theta will vary to here. Respectively, there will be this line, this projection should also vary. So, this will vary in this direction. So, the first point P was here, the first point P was here, and the second point P dash is here. So, the shift is denoted by this red arrow, and which is directed along the direction of phi cap. So, we got the direction. Now, what is its magnitude? We know that from here this and this will be same, these two arrows are the same. Now, here we got an angle, that is a d phi, and we have an arc, that arc is marked in red, and these blue lines are r sin theta, that are the radius. So, if I draw a particular picture for that, they will look like something like this. Sorry. So, I draw it. So, this is r sin theta, this is also r sin theta, and this angle is d phi, and this is my arc. So, that arc is equal to r sin theta d phi, and it is directed along phi cap. So, we got all the three line elements. Here the line element is r sin theta d phi phi cap. Here you can see, let me get it together. So, the r variation causes a line element dr into r cap, and the theta variation causes r d theta. Why there is a something? Why it is not just d theta into theta cap, instead of there is an r additionally there. So, for x we know that it is just dx, and for y it is dy, and then why for theta it is not d theta, instead it is r d theta. There is a coefficient r. Why is it so? That is because d theta is not a variation in length dimension. So, to convert the corresponding change in, that is here d theta is a change in angle. So, we have to convert it into the change in length. So, for that we need that r there. So, it converts it into the length element or into the dimension of length. So, phi variation causes r sin theta d phi phi cap. So, together we can sum it up to get the dl. So, the dl for the line element for spherical polar coordinate system is dl is equal to dr into r cap plus r d theta into theta cap plus r sin theta d phi into phi cap. Okay, that is about the coordinate system, spherical polar coordinate system, which is very useful when you learn physics. In the whole life of physics, you will see many times this coordinate system while you learning hydrogen atom, quantum mechanics and everything, there will be this. So, in electrodynamics in particularly, it is very important. Now, let us go back, go to the next coordinate system, that is the cylindrical coordinate system. So, now let us talk about the second coordinate system, that is the cylindrical coordinate system, which is much easier than what we learned before, the spherical, because one of the component, two of them are the same as before, what we have seen before. So, let me say the purpose of it is to find the coordinate of this particular point P in the space, and in this cylindrical coordinate system we define its coordinates as s, phi and z. In some textbook you will see instead of s you will see a rho or something, a rho or r are used. So, we are using here s. Mostly it is used in many textbook, it is used as rho. So, when we are dealing with charge densities, you may get confused with that rho. So, we use s instead of that. So, the coordinates are s, phi and z. Now, let us define each of them individually. So, this is s. What is s? S is the distance from the z axis. So, the perpendicular distance from the z axis, not from the origin or something. So, if the point P is somewhere over here, P is here, then this will be the distance s. Now, if this is the point, this will be the, here it is. So, if I am fixing the s, okay, if I am fixing the s, say s is equal to some 5 centimeter, then I can find many points, infinitely many points. One is here, this will be at a distance 5 centimeter, this will be, and similarly to this side, this side, this side. So, to downwards also. So, if I collect all of this together, I will get the surface of a cylinder. So, s is a constant, means that is the entire points, those entire points which s is equal to constants lies on the surface of a cylinder. That is why we call it as a cylindrical coordinate system. So, that is first coordinate, that is the perpendicular distance from the s. Okay. Now, let us go to the next one, that is the same phi. Now, here there is a small difference, that is phi is same as that of the cylindrical, that is we take the projection of r, but here there is a difference. We do not need to know the difference, or we do not need to have the projection of r vector here. So, we had an r here. In the previous case, we had an r here, we took the projection of that. Here, we do not need that. Why? This s itself be projected as this. So, we do not need the projection of r, instead of S will make an image of it at here. So, this is not r sin theta as you seen before, this is just S. So, we got S there. Now, this angle, this particular angle, that is the projection of S on the xy plane, which makes with x is called the phi, which is similar as that of the in spherical coordinate system. Now, the next one, so we got S, phi, and the last one is the Z. So, Z is same as that of the Z coordinate in the Cartesian. So, in this particular coordinate system, we took two of them, that is phi from the spherical, we borrow the same one, the phi from the spherical system and Z from the Cartesian system. So, this distance, so how much it is at a height in the Z direction is measured as the Z, that is the Z coordinate system. So, we got it, and respectively we can find its line elements as, so if I vary S, you know that S, the variation of S means it corresponds to a length variation. So, the next, if I increase S by a bit to here, so the corresponding direction will be, the next point will, the direction will be like this. So, this is the ds into S cap, and if I change phi by an amount as you seen before, that in that case it was r sin theta d phi. Now, instead of that, you see here r sin theta is now it is just S. So, that will be the corresponding to phi, there is a variation, and that is, so the phi variation causes, so the phi variation causes a coordinate or a line element, that is S d phi into phi cap, and now this is Z. So, we know that is simply dz into Z cap, which is same as that of in Cartesian system. So, the line element is dl is equal to ds into S cap plus S d phi, sorry I missed something here. So, ds S d phi into phi cap. So, we need the direction because it is a vector, and dz into Z cap. So, this is the line element in cylindrical coordinate system. Now, with a better understanding on this coordinate systems, we can move to find the curl of electric field. So, that is the del cross E. For we can do that in Cartesian system as well as in spherical system, but in Cartesian system this it will become very complicated, the mathematics is getting very difficult. So, we can do it very easily in spherical system, that is why we learned this all coordinate system with by spending some time on that. So, next we will calculate the curl of E using the knowledge from the Cartesian system, from the spherical coordinate system, and also from the previous knowledge. So, previous knowledge from the vector calculus classes. So, combining them, combining the knowledge all of them from, so combining all of them, we can calculate the curl of E here, that is the curl of electric field, and from which we derive a new quantity, a scalar quantity that called potential. So, we will do it in the next class. Thank you.